Hey, welcome to the BlockVigil webinars for Ethereum development. And so we'll just take a quick walkthrough through one of our tutorial frameworks. The idea here being that we work on some smart contracts on an Ethereum test network. We see how uh, we can operate on the smart contract. We can take a look into the Ethereum transactions, and then once we kind of get through that basic stuff, then we'll start going a little deeper into what we have as part of the Ethereum protocol itself, not just working on it. And then we'll take up some questions and answers from people who would like to know more. I'm Anumit. I'm the co-founder of BlockVigil. We have been building this stateful API gateway on top of blockchain for about a couple of years, and I also have my co-founder with me, sitting around me. We'll be coordinating together on bringing you this webinar. Let's hope you learn something useful out of this, right? Yeah. So we'll just get started on this. So if you load up tutorials.ethvigil.com, you get to see email box. Actually, what we do have here is a little bit of overview of how we envision this tutorial framework to help you through your journey as a programmer on blockchain. And to get started, just enter an email address so that we can have a track of your progress as you go through the lessons, because we plan to give you your rewards and recognitions based on the activity you complete through the lesson plans. And so I'm gonna put something that works for me. Right. So if I just go back to my email before I begin this process, I'll have a email verification. This is where I'm going to just verify my email and get a confirmation on that. So I had a setup tutorial earlier, hence you're seeing a completed status. I'm going to go back to the fresh new tutorial instance so I can take you along this journey. And here I've just quickly laid out the lesson objectives. The very first one, that what exactly are smart contracts and what work you do on them. So you can deploy a smart contract. First of all, that's a very different terminology coming from web development or even developing on a desktop, because usually you have an executable or you have a script that runs on a server, and once the server starts serving a file, that's it. But here you have a deployment which fixes an instance of a contract, and on that instance you get to have a read or write. Think of it as instantiation in a memory within a desktop, but now this happens to be on the entire blockchain network and it doesn't go away. You cannot delete it. So that would be an analogy between the usual desktop development and development on blockchain. Once we go through the very first lessons details, that you will slowly be introduced to what will be the steps that are going to help you as you get along on the journey. So try not to skip any steps as we go through the lessons. That would really help you. So usually what happens is a smart contract code contains storage variables or constants which act as stores of data, and they can be set to hold the state of a smart contract. Like if you have a string variable which holds a identifier of that contract, or some sort of license key that can be said to be a state, and on these data stores you do operations or you read from them through something called functions, very familiar to people who program. The functions can either read or they can change the stored values, and this creates the contract into a new state. It's no more in the older state once I call a function that can change a stored value. So here I'm looking at a very simple code for a smart contract in a language known as Solidity. And quickly, if you can see over here, this is pretty similar to how you will see it in C++ or Java, where the string variable is declared to be private in a contract known as hello world, and the constructor is of course the one that is called the very first time the contract is instantiated. It sets the private name to a value of hello world. Now coming to the part where we explained what functions are. So let's say I want to read some data from the current state of the contract. For that purpose I have a get contract name. It's a very simple function that returns the name variable, and then we have the writable function that changes the stored values and hence progresses the contract to a new state, which is called set contract name, and I'm passing it a certain string that gets set to the private name variable. And that's all that is there to this hello world contract. And I'm going to just go ahead and deploy this and allow our API gateway to take care of the deployment. As you can see, it says over here waiting for contract deployment. Perfect. So right now we are just monitoring what the status of the contract deployment is. And here we go. As we see step is completed, we take a step-by-step approach to the lesson like I mentioned earlier, and the very first step was deploying the first contract. We did the work of tracking the deployment status of the contract. We got the deployment contract's address. So this is a 160-bit value, so there are about 40 hexadecimal characters, and this is where you can access the contract code on the blockchain from now on and till forever. It doesn't go away. It always stays at this address. We have linked this contract address to a website called Etherscan, and this runs as a blockchain explorer which looks at blocks, and it allows you to read through transactions and whatever is happening on the chain. And as you can see, it says Goerli test network. Goerli test network is just an Ethereum test network which doesn't incur any actual dollars or currency to make any transactions on it. So as you can see right now, this is a contract which just got deployed. We just linked you to a different provider to show you that it is actually happening on the blockchain. It's not going anywhere else, and you can see that it has just been deployed about a minute ago, right? And we did the work of tracking the status of deploying the contract till the point it got confirmed on the blockchain. So we can move on to the next step called reading from the smart contract. As we saw earlier, the smart contract code does open up a function called get contract name, which is declared as public, and also which is declared as view. We'll take a look at what view means, but public means it's accessible for me to just call it, and which will return me the name. Now what happened is we have a API gateway which automatically will generate an API endpoint for you, the one that I've highlighted over here on betaapi.ethvigil.com. You pass the contract address that got deployed. If you remember, on the very first step, we deployed the contract at the 0x1a ... this big 160-bit hexadecimal address, and we construct a path out of it with the method we want to call, which is get contract name in this example. So this is a function that is supposed to read from the smart contract. What we do as part of our API gateway is we construct a HTTP GET request. So any smart contract functions that are read-only on the smart contract code gets converted to a HTTP GET endpoint on the ETHVigil gateway. Now, how do I call this endpoint? There are quite a few ways. There's a very quick way to do it. If you are a developer on Mac OS or Linux, you have a tool called curl. On curl, you can call a command like this by opening a terminal where you copy and paste this command. That's all. We have auto-generated this for you as part of this tutorial. Right. So once more, I'll go through the whole structure of what am I doing over here. Curl is the tool, get is the HTTP call. Here is the endpoint automatically generated by the api.ethvigil.com /contract / the address of the contract / get contract name, and you have this header that we are passing over here. I have a FAQ at the end of the tutorial section where you can read what are these headers that are being passed. These are HTTP headers. Let's go ahead, open the terminal and paste this contract and run it. Let's see what happens. Here I am. I paste the contract code and I press enter. Right. If you notice, I just did a entire tracking of the status of completion of this step by calling curl. It returned you a certain data structure. This is called a JSON data structure, where we see the data to be returned to us as a string variable, and of course it returns the currently stored value of the variable name. This is usually how the responses from the ETHVigil gateway are structured. They open up a JSON structure which contains a success boolean flag, and within the data field it contains what are the data being returned. Currently we are just getting a string value that's returned, and the string value is not assigned any name, it's kind of anonymous. So we return the same to you, saying this is a string return and containing the actual value called hello world. If you want to further read about what exactly curl happens to be, and if you do not have terminal installed on your operating system, you can go through these small little points on how to install the terminal and the curl software on your operating system, so you can go ahead and run this command and read from the smart contract. Moving on, if you see, the step 2 reading from contract has been checked as true once you completed the call. We got to know it because you did a ETHVigil API call and we were tracking your request. Now comes the part which is in my opinion the most interesting part of developing on a blockchain. You're writing to a smart contract, and if you go back to what we began with, this string private name, this happens to hold a state of the smart contract which at initialization was known as hello world, and as soon as you call a set contract name and you pass on a different string variable, it changes the stored value over there, and this changes the state of a contract, and that kind of forms the very basis of what blockchain is, changing of state of a contract as you keep writing to it. Now what we do need to see over here is the earlier call was a HTTP GET request, but with the GET request you cannot modify any data, right? So you have the automatically generated API endpoint, as you saw even in the earlier step, against the function called set contract name. The method that will be accepted on it as part of the HTTP verb won't be a GET, but it will be a HTTP post. Through the same curl request, we can see that we pass a post method call this time onto the automatically generated endpoint for the function set contract name. So it is once more beta-api.ethvisual.com, pass on the contract, then the address, and then the function name. The headers will say that we are going to work on a JSON data structure. We pass an API key. This identifies your currently registered account with ETHVisual. This is an API key which is passed as an HTTP header, and this is something that is well known in web development, where you pass something called form data, which are about key value parameters basically, to a method called set contract name, which directly corresponds to the smart contract code. The smart contract code expects a underscore name parameter, and the argument against this parameter is passed to the ETHVisual API gateway called, so this is a string that I'm writing called name equal to change name. So it could have been any string, not a problem. Let's run this command and see what we get out of it. As you can see, as soon as you send the contract, we know it's step in progress. It returns you something called a TX hash. It's a transaction identifier, so that you know how you can identify this transaction on the blockchain network. Just like how we had a fixed contract address, you have transactions happening on the contract, and we will be tracking this call onto the smart contract, and once it gets confirmed onto the blockchain, we will show you the update over here. So you gotta wait for a while. There we go, step complete. We just finished writing to the contract. Now we had a transaction hash that was returned to us. Let's take a look at that. Here is the value. This identifier can be traced once more through a different provider. I'm going to use the same Etherscan provider over here. So this is how we check. We go /tx/ enter the transaction hash, and there we are. It has indeed been a success, and it has indeed been sent to our contract, the same one, 0x1s7b. Here we are. This is our contract. The transaction went through on this contract. And to remind you, the goal of sending a transaction to this contract was to change the private stored variable's name, which is supposed to be this camel caps value called change name. Here we will go back to this area after we're done with this fourth step. I'll revisit this area. But how do we know that whether the name variable has checked? If you remember, the get contract name defined on the smart contract code returns you the currently stored value of the name variable. So we're going to once more do what we did it in step 2, which is to read from the contract. We're going to call the same get contract name method, and we're going to verify whether the state actually changed or not. Oh, okay, there's a confetti. I didn't know that. Mm. We see that the string that is written now is changed name, and it is no longer the hello world value that was there in the beginning of instantiating the contract. So this kind of tells you that, right, the value of the variable stored inside the contract changed. So as a whole, the state of the contract itself changed. Now, that's the whole point of having a transaction. It moves the state of a contract from, let's say, state n to state n plus 1. It's just the next state. And a bunch of such transactions are included in a block. So that can contain transactions for other contract addresses too. Of course, there are a lot of contracts running on the blockchain. And then there are people also exchanging value onto the network. For example, on the Ethereum network, people do a simple transfer to some other party over some unit called ethers. Ether is what is the unit of currency that moves across the Ethereum network, that denotes the value required for transactions, and that also denotes a certain sort of balance that is associated with your account. So the account section is something that we'll be introducing in the next lesson, in lesson 2. But for now, you got to see what a transaction can do to a contract, and such transactions are included together into something called a block. These blocks are what are literally the building blocks of a blockchain. You connect such blocks to the previous one, and the chain of such blocks literally forms a blockchain. And the other way of looking at it is, if you take the state of all possible smart contracts and accounts on the Ethereum address, they start from a certain state, you apply certain transactions from a certain block onto it, and the state of the whole chain moves to a different state altogether, and so on and so forth. So this is in the Ethereum world, it's also known as a world computer. So much of the logic in the lowest layers of such blockchain protocols, they consist of peers exchanging their versions of the state, because now there is no one server that we talk to, and coming to a consensus on it. This is where a lot of the research is also heavily involved. So you have proof of work algorithms, you have proof of stake algorithms. In any case, we are not going into what proof of work or proof of stake is in this webinar, at least. But the whole fact that you have a global state which changes according to the transactions being passed through, this makes the entirety of blockchain something as a state machine or a deterministic finite automaton. In computer science, these two are very commonly known concepts to model a system's behavior. So here the system as a whole happens to be the blockchain, with all the accounts and contracts and the transactions happening on them. This is, I took the images from this article. It's actually a good introduction to Ethereum. If you wish to go through it, just click on it and you can read through it and learn a different way of looking at Ethereum. So far we have actually gone through lesson 1, and there are quite a few concepts here that you might need a rereading through, and once you start applying your little detective skills, so let's say I start looking at where did this transaction come from, like this, right? I start seeing an address over here. So this is something that is known as an Ethereum account address, and then we have 2, which happens to be a contract address. On Ethereum, they both are identified by the same 160 bits. It just so happens that address as a contract address happens to contain a code that can be executed, while a usual Ethereum account may be held by an individual. It can only contain account balances, and it can send transactions to other contracts. For example, if we look at this from which sent that transaction, there are a bunch of transactions that happen here, and it has been happening since the past 10 days. And quite a few happen to be contract creation, so we have created a bunch of contracts through this account which ETHVigil is taking care of, and you didn't have to pass any private keys to identify by that account. All you had to do is make a call, the deployment goes through, and once it goes through, you have the address, and on it you can do a standard construction of an API endpoint. It's very standard. So this is the API endpoint prefix, which happens to be the beta API in our current example. Our mainnet has a different API. You pass the address of the contract, and then you pass the function which you're going to call. If it happens to be a read only function, you pass a get method, as we saw in the last step. This is a get method. If it happens to be a writable function, you pass a post method. What are HTTP get and post methods? I do have a section included later on. If you look at this, what exactly constitutes a REST API, because that is how we aim to model your smart contracts accessible as HTTP API endpoints. And the accepted standard is that if you're not modifying a data and you're just retrieving and accessing information, you use HTTP get methods. And if you start to modify a sub resource under a resource, which happens to be set contract name, which is modifying the internal variable name, then we use a HTTP post method. And a little bit of knowledge on using a command line tool really goes a long way in quickly testing your API endpoints before you start writing any sort of code, whether it's on Node.js or whether it is on Python. That doesn't matter, but this is a quick test. We wanted to show you that when you use the curl command tool, you can pass a lot of options that are very easy to pass along. You pass a header. Why do we pass a header? So it tells you what exactly the HTTP request is supposed to do. It should work on a JSON data structure. It identifies the person making the call with an API key that is identified on the ETHVigil API. And remember, whenever there is a REST API, there's always an identifying information involved. Otherwise, you're not supposed to modify resources without authentication. That's not how it's supposed to be done. And then we have the actual parameters being passed to set contract name through a concept known as form data, and that we identify in this header called content type. I tell it's a form data being passed, and then I start passing parameter. In this case, it happens to be just one parameter, that is underscore name, and the argument for this parameter is this string variable called change name. Actually, as a matter of fact, I want to show you, you can also make a call with a different variable. So instead of change name, I can, let's say, write Anumit, and we can see there is a transaction hash that has come through once more, right? This is not part of the tutorial, I just wanted to show you what's going on, right? So we can see there is a transaction hash returned against set contract name, and I want to track it once more through our third-party tool. Let's see what's going on. Oh, looks like it has gone through. Okay, maybe this should have changed the stored variable name. I'm once more calling get contract name with the curl command, and here we are, the string has been changed. So through this session that we have been setting over here, we managed to take the contract through two state transitions. One was when you called the set contract name on this parameter, calling change name, that made a transaction onto the contract and that changed the state. Then I did one more where I changed the name variable to Untitled, which gave it another transaction hash, and it forwarded the transaction and the contract to a different state. And now we have Untitled stored within the contract as a state transition. Right. So this is something that happens as a transaction goes through to a smart contract, and the transactions now get identified by the Ethereum account address that's sending it out, which we saw once more as in the previous transaction. It comes right now. You will notice there is a pattern of all the transactions that have been happening so far. They will be going through the same from address. Let's see, let's find it out for ourselves. Here we are, just taking a look at two different transactions we are done. Let's take a look at this from address. Boom, here we are. Yeah, and that is the same from address. So for the sake of this tutorial, we have fixed which Ethereum account address that sends your transactions to a smart contract, so we can keep certain uniformity in who's sending the transactions to a contract. The API gateway abstracts that away for you, that who is going to sign the transaction and identify as the sender of the transaction, right? So that sort of completes the lesson one. Of course, it was a very basic introduction into what a smart contract is, what code happens to be inside, and interacting with the smart contract, whether you want to read something from it or you want to change something stored within it through a transaction, and how that gets supported by the BlockVigil API gateways as HTTP GET and HTTP POST calls represented in a RESTful APIs. If you have anything you'd like to know further, you should drop a comment onto the live chat so I know if you're looking forward to know something more. We got a question that how do we manage keys? Right. All right. That's a great question, actually. I actually wanted to bring up little presentation I had made for a group of beginners who wanted to learn blockchain. Let's take a look directly over there so we can exactly see what identifies an account on the Ethereum blockchain. That would be a great thing, right? Right. So you have a contract account which we saw a little while ago. It's a 160-bit address, and then you have something called externally owned account. So basically this is you, me, a certain person who holds a private key and a public key. That's what the question meant, by the way. How do we manage keys? So this is something known as the public key cryptography paradigm. You can read up on it later on Wikipedia. I've actually taken this illustration from Wikipedia. So you have you just generate two pieces of numerical values. It's as simple as that. That's what I can tell you. So this random generation creates two pieces of data. One is known as a public key and the other is known as a private key. So what happens is the private key is, as you can see, it's depicted in red, which makes it kind of sensitive information, because you can sign a piece of data with a private key, and the public key can be distributed to anyone. So through the public key you can verify on a private key signed data that this is the same person that signed it, without revealing the contents of what the data was. So looking back, when we looked at contract calls being going through a certain from address, this is what is happening on the end of the Ethereum API gateway, where we have the private key associated with this account in a secure vault. It's not actually stored anywhere. We don't get to store it. We don't even you don't get to touch that database. It's securely generated in a vault and it is stored there, and a certain account gets associated with your BlockVigil API key, and there are a couple of other abstractions inside it, but just know that it comes from a secure vault that your API key identifies on the BlockVigil API gateway, and then it does private key signing on the transaction data, and then it sends it out to the network. Usually this is how Ethereum account address is generated. So as you can see, if you have a big piece of data as the private key, it is used to derive a public key out of it, and this follows a scheme known as ECDCA, elliptical curved digital symmetric asymmetric encryption. Here you have the section of this public key which is picked up as an Ethereum address, right? And this identifies you on the Ethereum network. I've picked this depiction from a certain Medium article. I can link to you after the chat ends. Let me try to give it to you. Do we have any other questions? Let's take a look at ECDCA if we are not following up with any more questions. What exactly is this ECDCA? The digital signature algorithm happens to generate a public key out of a private key. So you have the private key privately with you, and that can always be used to generate a public key, and you distribute it out to others. So ECDCA, like I said, it's elliptical curve digital signature algorithm. It's an encryption paradigm. Once you start using these signature generation algorithm as part of this, you get returned a public key. And always remember, the last 160 bits of this big piece of data is used to slice out the Ethereum address, and you'll always be identified by this Ethereum address on the Ethereum networks. Do we have any more questions on? All right. So right now what we did was just the first lesson, and if we go back to the dashboard, it does give you a progress bar of sorts. So this is for the very first level. Of course, we have put up 4 lessons for you. You should just complete that, which opens up the later on levels for you. And as you saw, all the contract activity, transactions, deployments, they'll always be on the blockchain, and since they're going through our API gateway, they are being tracked against your account. and we will be generating the proof, a verifiable proof of this, that will be attached to a certificate that recognizes all the work you have done. And the next session that we'll be having will actually be going deeper into the sender of the transaction, the Ethereum key that we just noted, who signs the transaction, who is identified by it, and using that identification to restrict calls onto a contract if we want, or how it might cause a security risk. So that's something that I want to keep it for the next webinar. And do we have any other questions coming up? Otherwise, we'll call it a day for this webinar. Thank you for joining. I hope you have a good time developing on Ethereum. Please get back to us with any questions if you have. We are available on our Discord channel. If you go to ethvigil.com/docs, you can go through our documentation. If you go to tutorials.ethvigil.com, and there also you can go and join our Discord server. We're always available there to discuss, to work further, or any code, any doubts that you might have. So I'll see you there, I guess. Thank you for joining in. Oh wait, someone sent another. Is it possible for a transaction to fail? Yeah, it can actually. The transaction can fail. Yeah. I do need to show you a failed transaction for that. And even before I do that, let's just say that if I had in set contract name a part that would say that, okay, if it happens that you send a name that is not acceptable, maybe I have a, like a profanity filter on the name variable. So let's say someone sends an abusive name on the contract and they want to set it like that, it should be rejected. And that is actually allowed in Ethereum through something called a revert. So you can write code that can revert if it doesn't like the values being sent to it, or if it fails certain conditions. That's one case when it can fail. The second case it can fail is every transaction needs certain fees. You cannot give a transaction less fees than it needs to execute on the network, which can also cause it to fail. So there are two big conditions that can come. And usually what happens is, for the first condition, if the code wouldn't let your transaction go through for certain inputs and it might cause a revert on the transaction, you should ideally be doing the check as a programmer. But then again, doing that manually means you have to write another boilerplate on top of every transaction that you do. In our case, we'll see it definitely coming up in the next webinar, that the transaction estimates are returned to you whether it can be done or not when you do the call through the Ethereum API gateway. If it happens so that the transaction cannot execute with the past inputs, we won't send the transaction to the network and cause a loss of the transaction fees. We'll make sure that we'll preemptively warn you that this transaction is not going to go through. And then even after that, we do give you an option of forcing the transaction. We don't know what you're trying to test. On test networks, I guess it's fine. So yeah, that can happen. The second part of the transaction fees, once more, as part of the preemptive checks that the Ethereum API gateway does, we also calculate the transaction fees that are necessary to be set on the call. So we do not ask that from your end, right? If you happen to be a paying customer working on a mainnet instances, we will be topping up your account with certain subscription fees, which gets redirected to transactions, right? So in any case, we make sure that the transaction fees get set automatically and possibly at the cheapest level, right? Because we keep monitoring the network. Yeah, so transaction failures are usually these two large, broad cases. Okay, so tracking the question, I just saw two questions. I guess that's it, right? So we will definitely call it a end to the session now, right? Go through the rest of the lessons on your own if you wish to, right? Otherwise, we'll get back for the next webinar. See you soon.